Hello, everybody. I am Davud Babazadeh. I'm working in office in Germany. We're a research institute for information technology. Today, I will be talking about how we can use basically ICT relevant data to secure power system application or control. I will very briefly talk about our institute. Basically, we are core competence in ICT and information technology, very much focused on, for example, deep learning, cyber resilience architecture, multi-scale simulations, which basically we apply those skills in different domains. 4 domains currently: energy, health, manufacturing, and transportation. I'm from energy division. In each division, we have, of course, labs, which basically we can implement our ideas, our research there, and test them. We have also one in energy division. We call it CISA Lab, a Smart Energy Simulation and Automation Laboratory. Basically, we are building here a whole picture of digital energy system, from power system simulator to the communication simulator, a lot of OT devices. On top of them, also SCADA technologies we have, open source and also industrial, and different tools that we can use basically to study. I can put it in this context that we can build a digital twin of a system here because we have all the simulation tools that we need. If we go to the topic, actually previous speakers, they talked about the problem in the current and future energy systems. Of course, we have different challenges in energy system, such as integration of a lot of distributed energy resources brings uncertainty to system. Also, you have a lot of actors in the energy systems. That means complexity. And in such a structure, ICT can help. How we can use ICT for monitoring, for operation, for decision making, and that means ICT has a strong has a strong coupling to the energy systems. So they are kind of very much integrated right now. If we go back to the history, the question would be: does ICT can ICT failures lead to blackouts? The history says yes. So I just brought some of the examples here from the event Blackout in North America up to the recent one in Ukraine. All of those says that the cyber side or ICT side can be problematic. And this means that when we want to design solutions for power system, we have to consider ICT. We have to look more holistic and all the system as a whole, basically. The next slide, I want to go a bit detail in one of the examples, one of this event that happens to show you what was the problem actually. So in the event in 2003 in Blackout, the American one, the famous one, if you look at the power system side, it was a cascading event. It started from a tripping of some lines and then voltage collapse. This is how the system operator could see it. Normal operation, the first event, power system event, it went to the alert, emergency, and then blackout. However, it was the ICT side behind it. So there were some failures in this. So the failures started from the system, the state estimator, then some tripping of the lines, alarm system failure, the state estimation was fixed with the incorrect data, and so on. But the system operator were not aware of that that problem. So the ICT system status was missing. So if we could somehow provide this information to the system operator, maybe we could stop it here already in the alert mode, the whole event. This shows basically that ICT is important, and ICT status is also important. Today, I wanted to talk about one specific aspect which could help to deal with the cyber attacks or ICT failures, which is monitoring, which is continuous monitoring. In the next slide, I just brought a question here. How we can trust the information? Of course, all the decisions that we make or system operator makes is based on the information that they receive. But how can we trust this information? Normally, information has, at least in some of the research that we did in office, we categorize the trust facet of information, so how much you can trust information, in 7 categories. So functional correctness, if it's correct or not, is the security of the data, reliability of the data, and so on. Sometimes some of these aspects would be important for information or more highlighted, and then some not really. But however, this aspect, there are some sources, some input we could get from the system that contribute in each of these trust facets. For example, for functional correctness, you could have the physical law to check. For security, sometimes you can do anomaly detection or intrusion detection system. And for reliability, the same story. You could have historical data on the correctness of the data, and so on. We believe that attack, basically cyber attack, showed itself in one of these aspects. So if we could monitor this aspect of or trust facets, basically we could detect hopefully we could detect the cyber attacks. To kind of test this, before that I go to next slide, which I show you what was the problem actually. In current status of the system, you have the power system. You can see here you have some communication devices or measuring devices, control devices, IED, RTU, whatever you call it. Then you have communication network. The information goes mostly voltage and power, or the power system measurement data goes to the SCADA system. You have a state estimator. Sometimes you have a bad data detection on the inside the state estimation, which is mostly working on the measurement data itself, the quality of the measurement data, and that's it. But the operators are kind of partially, you can call it, blind from the malfunction of the ICT or attacks. What we propose is that to integrate the health information of both OT and IT system to the state estimation, or to, if you call it state estimation, or the SCADA system. And that means that the information from communication network, from the health of the devices in the communication, like the routers and so on, the traffic information, the information about the performance of the electronic devices like RTUs, IEDs, they could be captured. There are tools already I introduced in the next slide. They could be kind of captured, they could be monitored, and basically any type of problem in this information could be collected as an alarm or event, and then goes to some kind of a complex event anomaly detector, and from there the kind of the information, the measurement data could be kind of tagged with the trust values, which comes both from power system side and ICT side, and then go to the state estimator for the calculation, and then later to the operator. If you look at this picture, you already see that there are multi-domain aspects involved, and for each aspect of this test, you might need a tool, and basically you need a tool chain of that. To do so, we try to pick in office as so the tools that could help us. For us, one very important aspect was the real-time performance of the tool. So because we wanted to test some point also the device itself, so real-time simulation was a very important requirement for us. So for power system modeling, we are using OPAL product. Then for the RTU, we have both physical RTU and kind of software-based RTUs at office infrastructure. Then for the simulation of communication, we used SCADA product because it has real-time performance capability. And then those information went, as I mentioned, to the ICT monitoring tool. We use some open source like CheckMK, intrusion detection system, and then anomaly detector, which we built here in office with the help of University of Oldenburg. And then this then a tool or a state estimator which was developed by University of Queensland that we used kind of a tool chain for that. If we go to the use case, for the use case we used IEEE 39 busbar model, which we tried to attack 4 busbar, which has sort of could be kind of islanded. The type of cyber attack here was false data injection to the RTU. So the attacker basically showed a different picture of the system to the operator, or tried to do that. And this information went through the SCADA and communication network to the control system or SCADA system. And this in a base case scenario, we just send the power system data to the normal anomaly detector, power system data to the state estimator, and you could see the kind of the information of the voltages on the bus bars. And the state estimator, this estimator has a capability to show us the uncertainty of the values. And a classical configuration without the information from ICT, everything was kind of correct. There was no uncertainty, and operator was thinking or is thinking that everything is fine. However, when we added the information from the ICT side, we could detect that the attack on these 4 bus bars, and the next step would be, and we did not do it in this study yet, is to take out this information. Of course, you could, for example, go for the historical data to replace it, or take another measures there. There's a published paper already that I have in the slide, the references. You can go and read in details. I was asked to show a demo that how this whole tool chain works. It's very complex to run it in real time, and normally something doesn't work in the lab. Therefore, my team, we prepared a very nice video of that. So this is how it works in the lab. You have information from basically OPAL simulates the power system. The data goes to a virtual RTU, software-based RTU. We have an interface there to kind of inject different type of attacks. In this case, data manipulation. And this data passes to a SCADA system in real time. Of course, if you want to look at the attacks in the network itself, you can use the libraries from SCADA. They have a very rich library for that. But we were looking more on the data manipulation. That's why we did it outside. And the data goes to these tools in the SCADA system, intrusion detection in the SNORD, and ICT monitoring, CheckMK. The alarm will be created, goes to anomaly detection, and then to the tool, which is our state estimator. And basically the whole chain works in real time. That is what we did in the lab. To summarize, I have one slide to conclude the talk. Basically, we believe that monitoring-based decision making could help to increase the security of the system. The other aspect is that ICT, as I showed in the use case and also the attack, the history of attacks, the ICT is integrated part of the power system. So when you want to test your solutions, you have to you go for a holistic approach as a whole, and also realistic environment, which means real-time simulation, hardware-in-the-loop testing, and these are two aspects which you should consider. And at the end, I showed you the tool chain. This tool chain had 5, 6, or 7 tools, or 6 or 7 tools actually. And this means that people from different domain expertise, they should talk to each other. And one big aspect of our group is that, competence our group is that we have people from different expertise, from power system, communication, computer science, data analytics, and this helps to build such scenarios. And I think collaboration across the domain should be really encouraged. And by then, I would like to end my presentation.